Okay, everybody, so we're back and we're going to be doing Pythagorean Theorem today. So, the Pythagorean Theorem, this is going to be the formula a squared plus b squared equals c squared. When something is squared, that means that you are multiplying it by itself. So if I told you 3 squared, that means 3 times 3. Okay? So that's what we're doing. When we have anything raised to the second power, that means it's squared, that means it's multiplied by itself. We also are going to have this symbol right here. This is called a radical. A radical is basically telling you to take the square root. Okay? So the square root, that can be anything like if I said take the square root of 9, that is a perfect square, so it gives you a whole number, which is 3. Whenever you take the square root of something, it will not always be a whole number. Sometimes it can be a decimal. So if you took the square root of something like 3, 2, 5, anything like that, it will be a decimal, okay? So only numbers that are multiplied by themselves are going to give you square root. So 5 times 5 is 25, therefore the square root of 25 is 5, okay? Now when we set up the Pythagorean Theorem only works with right triangles. Remember, this symbol right here, this little square, lets us know that the triangle is a right triangle. We have our sides A, B, and C. What you need to know is C is always the biggest number. Okay? This is one of those few times in math where we say, okay, is this always true? Does this always work? Yes, C is always the biggest number. Okay? So, we're going to look at some example problems right here. We have number 1. We have A equals 3, B we're looking for, and C equals 5. So, an easy way to start this is if we were to take and draw this out like a triangle. Okay? I'm just going to have this triangle be based off of this one. So I know A is right here. So A is 3, so A goes here. Okay. B, we're looking for that, so we're just going to put a B here because we don't know what it is yet. And C is 5, so we put it here. Okay. Now we're going to set it up in the Pythagorean Theorem. Well, A squared, so that's 3 squared plus, still don't know what B is, B squared equals 5 squared. Alright, so we just had to plug those numbers in, and now we're going to figure out what 3 squared is and 5 squared. Well, 3 times 3, remember squared means times itself, so 3 times 3 is 9, plus b squared equals 5 times 5 is 25. Okay, now we're wanting to get b squared alone. Remember, when we worked on manipulating equations before, if you want something by itself, you have to do the opposite operation in order to get that thing by itself. This 9 right here is positive. The opposite of that would be a negative 9. Therefore, we have to subtract. So I subtract here. Well, if I do it to one side of the equation, again, I have to do it to the opposite side. So subtract here. 9 minus 9 is 0. I have b squared equals 25 minus 9 is 16. Alright. Now here is where our radicals come in. Okay? So the radical is the opposite of squaring. Taking the square root of something is the opposite of squaring something. Kind of like how multiplication is the opposite of division. So in order to undo this, in order to get rid of it, I have to take the square root. Well, I did on one side, so what do I have to do? Exactly the other side. Take square root. And remember we said the radical gets rid of the square, so those two cancel themselves out. We have b equals 16. Well, I know 4 times 4 is 16. That means 16 is a perfect square. The answer is 4. Therefore, our missing side is 4. Okay? Now, that is what it looks like if you're missing A or B. Okay? If you're missing A or B, this is what this is going to look like. Now, if you look at the next problem, we have A and B. We're trying to find C. So this one is a little bit more straightforward than this one, because I already know what 2 of these things are. I already know what A and B is. So, if I drew my triangle again, I have 3 for A, 4 for B, looking for C. Okay? So, if I have my Pythagorean Theorem, plug it back in there, 3 squared, 4 squared, C squared. Okay? 3 times 3 again, 9. 4 squared, 4 times 4 is 16, C squared, we don't know yet. Now, they are on the same side. Therefore, you just add them. Add them together like normal. Imagine this said 2 plus 2 Well, what was 2 plus 2? It's 4. So we just add them across like you would do like that. So what is 9 plus 16? 9 plus 16 is 25. Still looking for c squared. Now, if you remember, back up here, we said that a radical, taking the square root, gets rid of squaring operations. So if I take the square root of both sides again, because you know if you do it on one side, you got to do it to the other, I have c equals square root of 25. 5 times 5 is 25, making a perfect square. So I have 5. So if you look here, we have found 1 where we're missing something on the left-hand side and where we're missing the right-hand side. Now look down here. If you notice, 5 is greater than 3 and 4. Well, 5 also happens to be c. Okay? That makes c the biggest number, keeping true with up here where I said c is always the biggest number. If we look at the first one, 4 is less than 5. Okay? That's how I know I did this correctly. If I somehow got b equals 6 or b equals 134, something happened very, very wrong. Okay? That would tell us we need to go back and start over from the drawing board. Okay? C always has to be the biggest one. So that is the start of the Pythagorean theorem. So this is what we're looking for and what I'm asking you to do with the Pythagorean theorem, just like these basic kinds. So we had just started with the regular way to do this without word problems, without all the extra stuff inside of it. So this first part was just kind of like a cut and dry, how do we do this? Now we're looking at some word problems. So in these word problems, you might get things with directions. That's why I have drawn this very artistically lovely compass off to the side. If you are ever confused on your directions, just remember it goes this way. The easiest way to remember it, never eat soggy waffles. Some of you just may remember it as I've been told in class, north, east, south, and west. I know the easy way, or the non-fun way besides never eat soggy waffles. This is just how I remember it. I will always draw this if you get confused, because remember, in between, if this is north, this is east, in between here is northeast. Okay? So, I have a word problem in my lovely handwriting. Please do not make fun of it, but I'm going to read it anyway. It says, Mr. Rhodes starts at a corner and walks 5 blocks north. He then walks 13 blocks to the corner opposite where he started. Find the length he would need to walk to get back to where he started. Okay, so we're learning some things from this problem. What we are learning is, first of all, Mr. Rhodes is doing a lot of walking today and getting his steps in. The second thing we're learning is how are we going to pull out the information from here in order to draw our picture to help us set up this problem. So, what we know that Mr. Rhodes starts at a corner. So Mr. Rhodes starts at this corner. Okay? He walks 5 blocks north. North is up. Okay? So I go up 5 blocks. And we'll say that this is 5 blocks. So this length of this line is 5 blocks. I'm just going to call it 5. And then it says he walks 13 blocks to the opposite corner where he started. Well, the opposite corner from where I started would be somewhere over here. Okay? So in order to get there, I would have to travel southeast, right? This is where we're going to have to do some thinking about this part, and the problem solving comes in. So if this is the corner where I started, and this is the corner where I'm at, well, they're opposite from each other, so they have to be on the same line as each other. So I would draw a line and connect those two. Well, that's a corner that goes southeast, and that was 13. Now it says, find the length he would need to walk back to get where he started. Well, to walk from here to here, this is what I'm looking for. So this part is what I'm looking for. Okay? So I would just set this up. We know it's a squared plus b squared equals c squared. A is here, 5 squared, plus, don't know what b is, we're missing b squared, equals, 13 is this long side. This is called the hypotenuse. If I haven't said that before, this is what that is. The hypotenuse is our long side, and that's 13 squared. So I have 5 squared, which, as we know from earlier, was 25. And then I have, let me write that down, b squared equals 13 squared. Well, 13 times 13 is 169. Okay? Now, we want to subtract these from each other. So I want b squared alone, so I subtract 25. Subtract 25, and I would get 25 minus 25 is 0. B squared equals 9 minus 5 is 4. 6 minus 2 is 4. Bring down your 1 because you have that left over, 144. Okay? Now, if you remember your times tables and you are remembering with the theme where we said that if it's a perfect square, if two numbers are multiplied by themselves, right, that is going to give us a perfect square, a whole number. So if we take the square root, because we have to do that square root to undo our square operations, do it on one side, you do it to the other, we would have b equals, well, the square root of 144. 12 times 12 is 144, making the square root 12. So I would have to walk 12 blocks to get back to where I started. Please make sure that you put your units when they give them to you, okay, unless it is specified otherwise. Okay, so that units, people have been telling me they're not sure what units are. Units are things like pounds, inches, feet, miles, yards, square feet, anything like that. If they have not given you units, but they tell you to use units, you would just say units squared. Okay, you would write out the word units like this, units, and then say squared, if they tell you to use units without actually giving them to you. Alright, we're going to do one more thing, that's the diagonal distance, and we will show you how to tackle that type of problem. Okay, so we're going to be back with diagonal distance. So let's say I have a square. This square has a side of 8. Well, here's the thing about squares. For a square, every side is equal. Okay, that is something that we know. We remember that from elementary school, 6th grade, I think a little bit of 7th grade as well. So if I tell you you have a square with side 8, well, you already know every single side is also 8. Well, if you know that, we already got this covered. We know that every single side is going to be the same. We got it. If I said find a diagonal distance between 2 points on this square, if I said from here to here, and I said find the diagonal, okay, we're looking for this part right here. Look what happened when I cut that square and made a diagonal into it. I just cut this square into 2 triangles, okay? So, because they are 2 triangles, and because a square, all this inside angles of a square are 90 degrees. Well, if I cut this in half, and I know that every inside angle of a square is 90 degrees, look what just happened, 2 right triangles, okay? That means I could use down here, or I could use up here to find the diagonal distance, which is here. We're going to call it C, because guess what? I can use the Pythagorean Theorem. Alright, we know a squared plus b squared equals c squared. We see it right here. So, a, b, looking for c. So, c squared, don't know it. A squared, 8, plus a squared, 8. Well, c squared equals 8 times 8 is 64, plus 8 times 8 is 64. Add those two together, you get the square, or c squared, excuse me, equals, well, 4 plus 4 is 8, 6 plus 6 is 12, 128. Okay? Now we're looking for the square root. Alright, now you may be thinking to yourself, that does not look like one of those things I learned in my multiplication tables. That is going to give me a good whole number when I take the square root, and you, because you are a super genius, are absolutely right. It will not give us a whole number. So we will take the square root of both sides, and this is where we're going to have to use some calculator magic. Let me put this one back here. We're going to use some calculator magic. The calculator magic is going to tell us when I take the square root of both sides, I have c equals, because the square root gets rid of squares, the square root of 128, and I'm going to show y'all on a calculator how to do this. If you have your phone calculator, you can do it this way. You can take your calculator like this. If you have iPhone, I think Android is the same way too. You turn it sideways, and look, it becomes a scientific calculator. Okay? So if you don't have the calculator on you, you got one on your phone, you can make it into a scientific calculator. On iPhone, you have to go 1 to 8, and I think it's all smartphones. And then you take the square root. The square root is this button right here. And we're going to get it to the nearest tenth. That's 11.3. Okay? That's how we're going to find that. You can also use those Desmos calculators that I and Coach South have put on Schoology for you, and it will do the exact same thing. But if you would prefer to use your phone, that is also an option, and that's how you do it on your phone. So I hope this helped. This was diagonal distance and Pythagorean theorem. Y'all let me know if you have any questions. Please make sure you're studying. And I hope this helped you on your homework and for your studies.